Welcome back. ELE 316, video 4. These are brought forward from video 3 when we were talking about Hurwitz polynomial. For a function to be realized, the denominator polynomial must be Hurwitz. And we may need to check. You don't trouble yourself trying to realize a network. You have to find out, is it realizable? One of the steps to find out whether it is realizable or not is to check the denominator polynomial. Is it Hurwitz? Some conditions have been given before. Your function, the order in the numerator polynomial and denominator polynomial, the order should not be greater than 1. So if the numerator polynomial, if the order there is 5 on the numerator, then the denominator polynomial must be at least S4. You can have S5 on the numerator and the S3 on the denominator. The gap is more than 1. So the gap should not be more than 1. Get me a duster, please. Now, this is brought forward, brought forward from video 3. We learned here that for a polynomial to be Hurwitz, PS is real when S is real. This is our takeaway from video 3. Also, the rules of PS must have real parts which are 0 or negative. It must not have pole on the right. The pole should be to the left. Now, we have some other conditions for a polynomial to be Hurwitz. 1, all coefficients are non-negative and non-zero. What do you mean by that? If you have S4 minus S2S3 plus 2S2 plus S plus 7, you can see that one of the coefficients is negative. So this polynomial is not Hurwitz because one of the coefficients is negative. Also, should any of the coefficients disappear, that means for S raised to power 2, the coefficient is 0. This is also not Hurwitz. Since we start from S4, every term must be present. Even if this is plus now, even though everything is plus, but that means there is a 0 S squared. One of the coefficients is 0. So for that reason, this is also not Hurwitz. So get it very well. All the coefficients must not be negative. All the coefficients must not be 0. And then number 2, both odd and even parts have rules on the j omega axis only. That we are going to be dividing our polynomial into 2, real part and even and odd. The EPS is even or odd. All its roots are on j omega axis. Continued fraction yields all positive quotient terms. So we now take some examples from our textbook. So the first one there is f of s equals s4 plus s3 plus 5s squared plus 3s, then plus 4. Now we are going to form the even and the odd. So we start. When you take the first one, you skip one, take the next one. Skip one, take the next one. That's for the even. For the odd, you start with the highest odd. S cube, skip one, you have 3s. Now, the next thing you do is now to divide. When you are dividing, you bring the biggest one, the largest one, 5s squared plus 4. Then you use s cube plus 3s here. S cube in S4, we are going to have s. S multiplied by s cube will give me S4. S multiplied by 3s will give me 3s squared. When you deduct, when you subtract, you're going to have 2s squared. Bring down 4. Now, this is like the remainder of the exercise. Now, what we now do is that we're now going to use this to divide s cube plus 3s. We're going to bring this down here. The former remainder will now be used to divide this. And then what are we having here? S cube, 2s squared in this, we're going to have half s. When you expand half s times this, we're going to have s cube. Half s times this, we're going to have 2s. When we subtract, we're going to have s here. And then the next thing we are going to do is to bring the previous one, which is 2s squared plus 4. So s into 2s squared, what are we going to have? We are going to have like 2s. 2s times this, that gives us what? 2s squared. 2s squared, yeah. When we subtract, we are going to have 4. When we have 4, we are going to bring the former divisor to this place, which is s. And what are we going to have? We are going to have like uh, 1 over, coming. We are going to have s over 4. When we expand s over 4 times this, we are going to have s. Then we are adding 0. You continue the division, continued fraction, you continued fraction. Then these are the quotients. This is what I refer to quotient. This is a quotient. Quotient. This is another one. This is another one. This is another one. We expect all of them to be positive. So if they are positive, that's a confirmation that that polynomial is Hurwitz. That polynomial is Hurwitz. So let's take another example. Example 10.1, you can see it. Example. So let's try example 10.2. Example 10.2 is giving me, we are giving that f of s equals s7 plus 2s6 plus 2s5 plus s4 plus 4s cubed plus 8s squared plus 8s plus 4. As usual, we start with s7 plus 2s5 plus 4s cubed plus 8s. N is going to be 2s6 plus s4 plus 8s squared plus 4. Now, we start as usual, 2s6 plus s4 plus 8s squared, 8s squared plus 4. We used to divide s7 plus 2s5 plus 4s cubed plus 8s. So what are we going to have? We are going to have half s. So this is going to give us s7 plus half s5 plus 4s cubed. Let me check again. Half, that is going to be s7, half s5, 4s squared, s cubed. Then we are going to bring this here now. 2s6 plus s4 plus 8s squared plus 4. What are we going to have? We are going to have, oh wait, I've jumped. We are going to subtract first. When we subtract, what are we having here? We are going to have 3 over 2s5, 4s cubed plus 4s cubed. That one goes plus 8s plus 8s. And then we bring this 2s6 plus s4 plus 8s squared plus 4. What are we going to have? This will be like this divided by this will give us like 4 over 3s. 4 over 3s times this. 3 will cancel, that will be 2s6. 4 over 3 times this will give us what? That will give us 32 over 3s squared. So if we minus this, we cancel this, we're going to have s4. We're going to have s4. This will be like 8 minus 32 over 3. 3 times 8, that's 24 minus 32. That will give us like minus 8 over 3s squared plus 4. Definitely there's a problem there. Let's check. So we got s over 2, we got 4 over 3, and then by the time we are getting negative here, definitely there's a problem. The book explained that s4 plus 4. So what they do is, so definitely we are supposed to be having positive throughout. Since we're having negative, there's a problem. The book conclude that the polynomial is not Lewis. We have example 10.3 there. In example 10.3, they actually got a negative. So let's try example 10.3 and see how this is. Although when we continue, we are plus here, we are plus here. But as we are going along, we know already there's a problem when you are having this negative. So that polynomial is not Lewis. So example, in this example, we are given that f of s equals s4 plus s cubed plus 2s squared plus 3s plus 2. This is what we are given in this case. So from here, we can form our, or even s4 plus 2s squared plus 2. N is going to be s cubed plus 3s. We start the division. S cubed plus 3s, s4 plus 2s squared plus 2. What are we going to have? We're going to have s. This is going to be s4, s times this, s4, s times this, 3s squared. When we subtract, we're going to have minus s squared plus 2. And then we bring this one here, s cubed plus 3s. To do the next division. Now, what are we going to have? We're going to have like minus s. Minus s times minus s squared, that will give us what? S cubed. Minus s times 2, that will give us minus 2s. When we subtract, this cancel, this becomes 5s. Because this is minus, sorry, they are taking light and bringing it back. This is minus, when we are subtracting, it will now be plus. And then we bring this one here. We have minus s squared. We have minus s squared plus 2. So when we divide, what do we have? Here, we are going to have minus s over 5 minus f over 5 times this will give us what? Minus s squared. When we subtract this, we cancel. This will be 2. We bring this here, 5s. What are we going to have? This will be like 5 over 2s. When we multiply, we are going to have 5s. When we subtract, that's 0. That's the end of the exercise. We have 4 quotients. 1, 2, 3, 4. We can see that 2 of them are negative. Even if only one is negative, that's sufficient to conclude that the function is not used. The function is not used. So with this, we have come to the end of examples of the Hurwitz polynomial. Thank you for having me. We'll meet again in the next video. Bye.